multiplexing is it can be very confusing, but it makes sense because we need it. In terms of networking, you think of it that we used to have telephone and internet under the same system, because for example, when you're playing games and then suddenly someone calls and your mom pick it up, your internet will be disconnected. It's under one line. So right now, using a software and hardware and mathematical calculations, we can split the signals and put it under one line. For example, you can listen to a radio signal and internet under one optical fiber. For example, right now your optical fiber, you're transmitting video, everything, audio, internet is under one signal, under one fiber optics. The most easiest way to separate the signal is by frequency division multiplexing. So let's say there's a highway, right? So you want to set the highway as signals that transmitted at the same time, right? Let's say they all start at 8 p.m., but you split them using different frequencies. For example, this highway, the lorry, which is the higher data rate, you transmit them at a different frequency, at a higher frequency. And then the lower frequencies below, let's say audio is a pretty low data signal types. So you put them lower, so it determines the frequency rate, and then you put it on division it. Now the second one is a time division multiplexing. They all send at the same time. It's all sent at 8 p.m., but this is usually used in digital signaling. But what happens is this: you allot for time division multiplexing, you set them by a time. Like one time, like you give every data a time slot. 801 seconds, you set A, B, A, D, C, B, A, C. So you set every 1 second, you give them a last time slot of data. Data B, data A, data D, data C. So the disadvantage of this one is that basically what happens is, for example, data B, like what I say, is a video data type of data, and it requires more data than audio, but you're still giving them the same time. So this is not really efficient, but that's what they use in the first place. You have a multiplexer, right? And then the multiplexer, when you receive on the server. Now this is the smartest way. I think this is genius, basically. Basically, what happens is that before you send the data, you send it as a time slot as well, but you create a frame on each data, right? And then basically the multiplexer will check which data it requires the most time. Whoever requires the most time, I'll give the multiplexer, using these formulas, that is using this method, he will give him the biggest time slot. This is basically it. Now we can go into details, but the concept is there.